Hey friends, welcome to follow up. Let's have a look at problem 2734, lexicographically smallest string after substring operation. In this video, we're going to follow the strategy that we're going to find the leftmost substring that does not contain the character A and change all the characters in it. Let's first look at the problem statement. So we are given a string S consisting of only lowercase English letters. In one operation, we can do the following. So we select any non-empty substring of S, possibly the entire string, and then we replace each one of its character with the previous character of the English alphabet. For example, B is converted to A, and A is converted to Z. So notice the second one. So Z is regarded as the previous one of A, right? So we are required to return the lexicographically smallest string we can obtain after performing the above operation exactly once. So notice that no matter what, we need to do exactly one such operation. So here, this paragraph explains what's a substring, which is to distinguish with subsequence. So here are three examples. For example, in the first one, so we replace CB by BA, so we get BA ABC. This is the return. And in the second one, we replace CBBC to be BAAB, so we get ABAAB, right? So in the third one, so actually we replace all the characters with the previous one. So we get this one. So the constraint for this problem are the following. First, the length is bounded below by 1 and bounded above by 3 times 10 to the power 5. And secondly, S consists of lowercase English letters. So this actually is also important. So with that said, so for this problem, actually we can look at the hint. So this hints here are very suggestive. So here, when a character is replaced by the one that comes before it on the alphabet, it makes the string lexically smaller, except for A, right? So then the hint 2 is also our strategy. So we are going to find the leftmost substring that does not contain the character A, and then we are going to change all the characters in it correspondingly according to the operation here. So now, with this strategy in mind, we are going to do two things. First, we are going to implement a verbose solution, so following this strategy. And then we are going to simplify the code a little bit. So in the process, we are going to explain the logic. So first, let's look at the solution we want. So first, I'm going to get the length of this string S. So this is for convenience. And then we want to find the start and the end of such string, which does not contain A, right? So we are going to use a flag variable called font. Initially, we are going to set it to be false. And also we have a start and end, right? So we're going to set them to be -1. And then last index, so we are going to make it as -1. So this one is going to check how long we can extend once we found a character that is not A, right? For example, here, start here, so the last index thing is 0. And then if we look at B, so if the last thing index is 1, then one less than the current index 1, right? So we're going to update the last thing index by 1, by the current index or. So this is the overall strategy. Now let's look at the specific process. So we're going to make a for loop for I in range n. So the purpose of this for loop is to locate the start and the end of the possible substring that does not contain A, right? So first we're going to check if Si equals A, right? So in this case, this can be the state that we haven't found some substring does not contain int, or we found, but this is corresponding to an int, right? So now let's check this situation. If we found a substring does not contain a, and then also if the last index sin is I minus 1, right? In this case, we send a, right? So we need to end the substring by I minus 1. So this is the one case. Another case is that if the current character is not a, right? So if not found, so we haven't found such character, then this will be the start, right? So there we're going to change the flag to be true, and then we set the start to be I, and the last sin index or last index is also I. So this is one. Another situation is that we have already found non-A characters, but we want to see if we can continue, right, to make a longest substring. So basically, if last sin index is either -1 or last index plus 1 equals the current index. So in this case, we're going to update the last index to be the current index. So this way, after this for loop, we're going to change the stage, found or start and end. So our main purpose is to find the leftmost substring or longest one containing non-A characters. So now let's look at some cases. First, if found and int is -1. So this corresponds to the case for example A, we have B, C, D, right? So the start will be index 1. So because we haven't met, we will not match another A, so the end will be -1. So in this case, we're going to adjust the end to be n-1. That is the last index, right? So this is the case. So now we're going to replace the characters in between start and end to be the previous character, right? What we're going to do is we can initialize a empty list, and then we are going to do another for loop. So for I in range n, right? So if I is in between start and end, then what we are going to do, we are going to append the corresponding character is SI, right? We want to replace the previous one in the alphabet. So we're going to do character, right? So the ordinality number of this one, right? So we're going to -1, right? Then convert to the corresponding character. So this is what the main logic. For the index outside this range, so we just append the original character. That is result append SI. So this way we are almost done. But now let's also look at an edge case. So in this case, we still maybe after we get we do this for loop, the found if still not found. In other words, the string is something like this, all A's. But due to the assumption that we need to do the operation exactly once, in this case, in order to make the resulted string lexicographically smallest, we just need to replace the last occurrence of A to be Z, right? So this corresponding to the following. So we're going to result pop the last A, and then we're going to append the Z, right? So this is the edge case. So this is the edge cases. So because it can be a certain number of character A's, but this A is also the unique character in the string. So now we are ready to do the return. So we're going to return the John of this result, right? So this forms a solution format to this problem, but in some sense, this code is long, and the purpose for this version of solution is to digest the logic, right? So before we make any comments, let's first make a test. Yeah, it passes one example. Now let's look at the generic case. yeah, it passes all the generic cases. So now let's examine the logic and slightly simplify the coding. I'm going to copy this part and put it here. I'll change this function name to be version v1. So overall the strategy is like above. We find the leftmost substring that does not contain n, and then we replace the characters respectively or correspondingly. So up to here, so that's the task of locating the substring, right? And then this is the replacement and the check of edge cases. So now let's look at another format or representation of the code. So for us, actually, once we located a non-A character from the left, and then we just need to directly replace all the characters follows by the previous one if it's not A. So once we meet another A, we just stop, right? So this can be mimicked or coded by a while loop. So now let's look at the case. So we start an index. Let me first get n. N will be the length of s, and then I is the start index, right? So we can make, in order to make it easy to work, we can make the string s to be a list. So this way we can do change or replacement, because list is mutable, while for a string it's not mutable, right? Then what we are going to do, while I is less than n and si is not a, right? So in this case, so we just need to increment this I, right? So once we exit this while loop, there are two possibilities. First is that I equals n. So in this case, it means that the string contains a unique character that is a, like the situation here, not found, right? So another case is that it stops in an inbound index, and then we meet another a, right? So let me correct. So another case is that we stop at an inbound index and we meet a non-A character, right? That's actually corresponding to the start in the first version of solution. So in this case, what we are going to do, let's first look at the edge case. So if I equals n, right? So this corresponds to the case like some repetition of a's, right? So in this case, we are going to replace the last character in the string to be the character z, right? So once we've done this, let's do the replacement. So it's going to correspond to this part. So we are going to use a while loop to mimic the process. So while I is less than n and si does not equals to a, right? So in this case, we just need to do the corresponding replacement. So what we're going to do, we are going to set si to be the character. So let's first get the ordinary number of this si. Then we actually subtract by 1, right? And then we are going to increment this I. So after we exit the while loop, one case is that I equals n. In other words, from the initial state for this I after exiting this while loop, then all the characters followed are non-A characters. So this is one case. Or we stopped at a inbound index, which corresponds to a character A. That actually means we stopped before this A, right? So now what we are going to do is again the same thing. So we're going to do the join. Let's directly copy this part. So what we are going to join is S itself. So now let's look at the test. It's wrong. Let's see where's the problem. I0, we have n, right? So we make S a list. Then while I less than n, right? So here, that's the logic. If si is still a, so we want to find the first index corresponding to a non-A character, right? So here we want to stop before the A character if it exists. So now let's do the test. It passes one example. Now let's look at the generic case. It passes all the generic cases. So that's basically about it for this specific problem. So basically, you can follow this strategy and write a solution. So in this video, we use the first version to digest the logic. In such a sense, the first version is a little bit verbose. And in the second version, basically, we did the same thing as the first version, but we optimized a little bit. So with that said, that's the end of this video.